everyone, this is a practice problem for quadratics that was on a old IB exam, and so this is practice for your upcoming IB exams. So we'll get started. There's much more than this. There's a H, a J, and K that follows as well. This is a long one. So basically it says sketch the graph for y equals 2 to the x from -2 to 3. So we know at 0, because they indicate where the curve intersects the y-intercept, 2 to the 0 equals 1. So we can plug that in. Let that be 1. 2 to the -2 is 1/4. So let's put that really close here. And 2 cubed is 8. So let's go for, at 3 we're going to 8, which is here. And we're just graphing in between here. So there it is, something like that's your curve. All right. Write down the equation of the asymptote for this graph. Well, the asymptote is this line. It has a horizontal asymptote at y equals 0. Then it says on the same axis, sketch this graph and clearly indicate where the curve intersects the x and y axis. So first of all, the y-intercept is at 3. So x is 0, y is 3. So 1, 2, 3. We know it opens down. So let's just get our intercepts and factor this. If you factor this, this would be 3 or 1 plus x times 3 minus x. I believe. Let's just make sure that's it. So we're going to get, I'm going to rewrite this a little bit. I'm going to write this as negative x squared plus 2x plus 3. So we're going to get a negative x, a 3 and a 1. And so we want this to be, our intercept is going to be -1, x equals -1. So this would be negative, and x is going to be positive 3. So here are your intercepts. Here at -1, excuse me, excuse me, I have a cold, and 3. All right, and then once you get those, it says clearly indicate that. We can look at our minimum and maximum values. We can look at our, let's see, right here, to negative b over 2a to get our vertex, f of negative b divided by 2a. So in our case, our a is -1, our b is 2. So we have -2 divided by 2 times -1. And that's going to give us -2. That's going to be 1. So we have a 1 for vertex. And now we plug in 1 to back into the equation to get, well, this one, to get our y. So y equals 3 plus 2 minus 1 is 4. So it's be 1, 4. So 1, this is 3, 4. So it goes like this. And this one we can continue on because I didn't restrict that. So there's the two graphs for that. And now we have to solve, let's move on. We have to solve this equation using the graphing display calculator. So for that one, you just put y1 and y2 and use your graphing calculator. This one is 8D. And you should get, when you use that, x equals negative 0.857. And we also should have x equals 1.77. So you can either use the second trace or second calculate and find your solutions for that. All right. Then we have E. It says write down the maximum value of this. So we already did that in the previous thing. Our maximum value is going to be here at 4. So we already did that to help us graph it, because that's the vertex. So your maximum value is 4. Use differential calculus to verify that your answer is correct in E. So let's take f prime of x equals 2 minus 2x. And so you set this to 0, and you get, let's see, when you set it up, you'll get 2 minus 2x equals 0. And this is going to be 2 times 1 minus x equals 0. So x equals 1. So when you have x is 1, you plug that back into your equation, and we already kind of did that. Y equals 3 plus 2 minus 1. That equals 4. So that shows we know how to use differential calculus to do that. And then it says, the curve, let's see here. The curve passes through this point. Use the information to write an equation down in terms of P and Q. So this is 8G. So you're just going to plug in your Y and your X. That's all they want. So negative 10 equals X times 2 squared plus Q times 2 minus 4. So this looks better written like this. For X, this shouldn't be an X, this should be P. So this would be 4P plus 2Q minus 4. And if you want to simplify that, we can go ahead and add 4 to both sides. So that would give you negative 6 equals 4P plus 2Q. And you can leave it like that, or you can divide everything by 2, and you get negative 3 equals 2P plus Q, which makes it look a little better. But that's all your work for that. And then the next thing we have to do is do these last 3 problems. So the gradient of the curve here at point, this point 2 comma negative 10 is 1. Find the derivative of y with respect to x. So if you find that derivative, that's just going to be derivative of y with respect to x equals 2px plus q. All right. And when you plug in 1, if you plug in 2, you know this should equal 1. So we're going to plug in 2p times 2 plus q. So you get 1 equals 4p plus q. So that is for 8h. And then for, let's see. Well, we did our derivative first of all. So 1 equals 4p plus q. And then we say, it says the gradient of the curve here is 1. Find the second equation in p and q. So that one's going to be here. And now we have to find p and q. So we're going to set them equal to each other. The two equations we got from here, the first one. So the two equations we got were 4p plus 2q equals -6. Or we actually divided everything. But I'm going to, remember we divided and we got 2p plus q equals -3. So that was the first equation. The second equation we got was 4p plus q equals 1. And now they just want us to solve for p and q. The reason we went here is we're just going to subtract. So when you subtract, you're going to get the 4p's cancel, and you're going to get q equals -7. Now if q is -7, so we have q equals -7, plug that back into one of these. I'll choose the second one. So you get 4p minus 7 equals 1. Add 7 to both sides. You get 4p equals 8. Therefore, p equals 2. And that's it. Thank you. Have a nice day. Bye-bye.